Howdy Algebra 2, let's look at 6.5, function operations. Doing operations, addition, subtraction, multiplication, division, all kinds of weird stuff with functions. So let's get a couple functions so we can do some function operations. Let's say f of x equals, so we need some functions, 2x minus 1. So this is a function. We say it's a function of x. You plug in a value there. You put the value there for x. Function. G of x. I'm going to snazz it up a little bit here. Oh, x squared. Ooh, beautiful. So what I want to know is, to write a function operation, I'll write something like this. I would say f minus g of x. And that just says take function f minus function g, and we're using the variable x. I could change this variable. I could write an a, and then we just write an a instead of an x. Okay, we'll just replace whatever is there, but we usually don't change that. So function f minus function g. And function g here only had one term. If it had more than one term, I need to use parentheses. So just for the sake of all time, if you just remember to use parentheses in general, you have to think of them in parentheses. But if you want to actually write them, that's fine. And I'd probably write this in standard form so that people think I'm smart. Very self-conscious. So function f minus function g is just that. There are no like terms to combine. If there's stuff to combine, please combine them. What I want to talk about domain real quick. We've talked about that a few times before. The domain is the possible x values, and the only thing we're going to note here is that you can't divide by 0. Well, look at this first function. The domain is going to be all real numbers. Why? Because I don't see any division. There's no division here, and if you look on the little sign to the side of the board there, it also talks about square roots and natural log, but we're really just looking for division for now. So no division, domain is all real numbers. Let's look at another problem. F of x equals x plus 3. And g of x equals x minus 1. Guess it doesn't really matter. I could make something up, but I have to go with what's on my page over there. So what I want to do is divide these. Let's say, what is function f divided by function g? I wrote it as a funky fraction of our variable x. Well, I'll just put function f on top. So function f is x plus 3. And function g is x minus 1. And that's it. That's your answer. But oftentimes it'll say, well, what is the domain of your new function f over g? And the domain is going to be all numbers except for when I divide by 0. I can't divide by 0. So you say the denominator for the domain, let me do it over here, for the domain, and just in general, I'll say the denominator, the D-E-N-O-M, I'm going to abbreviate it, the denominator can't be 0, because I can't divide by 0. Well, that's x minus 1, and then x can't be 1. So the domain of this function is all numbers except x can't be 1. All numbers except x can't be 1. So it asks for the domain, and it often does. If it's division problems, I say the denominator can't be 0. If it asks for the domain of just a polynomial with no division, just say it's all real numbers. One more thing, function composition. Function composition. Oh man. I'm not going to check the spelling. Function composition. I'm scared, but I'm going to go with it. You know what I mean? Sometimes you just got to be a big boy and go with it. So I'm going to have a couple of new functions here. Very exciting. I keep changing my functions. F of x equals x cubed. Very exciting. I have a cube there. Ooh. And g of x, we'll make that more boring. X minus 5. So to compose functions, you put one inside another. Let me do a couple things. First, I'm going to compose it with an actual number. So function composition, it looks like fog in this case. F of g. And I'll do the number 7 first. So when I read this, I would say f of g of 7. F of g of 7. And when I start to solve these problems, I usually write it a little differently first. I say f of g of 7. So I would say both these, f of g of 7 and f of g of 7. But I like this notation better because it tells me what to do first. It tells me to put 7 into function g, and I'm just going to do that in my head. What's 7 minus 5? What does function g tell you to do? Subtract 5. 7 minus 5 is 2. And then function f tells me to cube that number. So 2 cubed is 8. So f of g of 7 gives me 8. One other type of function composition problems they could give you, because they're sneaky like that, they could just say, all right, smarty pants, what's f of g of x? Well, I do the same thing, f of g of x. And in some ways, this is simpler. There's no operations to do, or there usually aren't anyway. Look at function g, x minus 5. So just put x minus 5. G of x equals x minus 5 instead of g of x, right? X minus 5. Beautiful. Now put this into function f. So write function f with parentheses. There's function f. It says take the number, whatever it is, and cube it. So take the number or whatever it is and cube it and put that inside. And you could multiply that out, but I don't think that would do you any good. In fact, I think it's simpler written like that. We could use the binomial theorem to expand that out, but what a waste of time and paper. What would it get us? Absolutely nothing. So those are your notes on section 6.5, function operations.